Welcome back, everybody. We are going to wrap up section 3.3 and with it chapter 3. Maybe that's good news. Maybe you're enjoying the conversation. I don't know. So that would make it bad news. But anyway, this is the last part of the section, and it deals with something called quartiles. And we sort of need this idea of quartiles to build this other type of graph that we're going to deal with called a box and whisker plot, or box plot for short. So quartiles are just another way to again make comparisons with data, and they when you hear the word quartile, what does it sound like? It sounds like quarter, and that's exactly what it is. First quartile is known as 25% of the data, quartile 2 is 50% of the data, and third quartile is 75% of the data. Now, quartile 2 has a special name. We know it as this little guy, okay, X with a little squiggly on top, which is the median. Okay, so if you see me write Q2 instead of the median, or you see me write Q2 or median instead of Q2, don't be alarmed. Okay, they are one in the same. So the median kind of comes back to us here. Now we've got really two ways to compute quartiles. Okay. The first way to compute quartiles is using the formulas that we had in the previous discussion, okay? And so that formula was the L equals N times P over 100, okay? That's the first way. And the second way is known as the approximation method, okay? And that's usually the way that most of us have learned how to make a box plot, is using the approximation method. So I'm going to show you two of them. I'm not going to run through all of the calculations that are on these set of guided notes. I've got the solutions for them posted on Canvas, and so I'll do one of these. I don't want to waste the time watching the mundane calculation. It's not the most exciting thing to figure out. So in example 7 here, I've got you computing all three quartiles. We're only going to do one of them, okay? And the rest of the computations really all follow along the same lines, okay? Make sure you follow those two rules that we talked about in the previous video. So let's do the first quartile. So it's using the previous set of data, which was on the miles per gallon. We're going to figure out what the first quartile is, and we're going to use what we call the percentile method. And percentile method means that formula, okay? Okay, so 25th percentile is what we call the first quartile. Okay, second quartile would be the 50th percentile. Third quartile would be the 75th percentile. Okay, so the formula is L equals N times P over 100. So N in this case was 135, right? 135 vehicles. The percent here is 25 over 100. And so we get 33.75. Remember, when you get a result that ends in a decimal, you have to round it up. So this should be L equals 34. Now what you have to do is you have to go to that stem and leaf plot, okay, that we had before, and you need to count, right, the 34th value. And I'll spare you those details of counting. You can watch the other video if you want to see more counting that we made before about using these formulas. And so the actual answer here is going to be 19.8 miles per gallon. Okay, so nothing too crazy. And then what you're going to do is you're going to repeat this for the second quartile, right? It's going to be 135 times 50 over 100. And the other one here, 135 times 75 over 100. If it ends up in a decimal, you go to the round up. If it's a whole number, then you have to take the next two. Okay, again, answers are posted on the Canvas website. Okay, so again, don't want to take the time away in doing that. Now what I want to do is talk about the other method, which deals with something called the approximation method, right? And so how do we use the approximation method? And what I'm going to do is I'm going to work only one of these, okay? I'm going to work letter A. And here's how this works. The first thing we have to do is we have to make sure that the data is in order, okay, from least to greatest. And so what you should notice is that actually in both A and B, that is the case, okay? So I'm going to look at letter A. Now, what we do is the first thing is to find the median, okay? And so let me count how many actual speeds we have here. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So n is equal to 14, and I've got a stray mark here as I was counting. Okay, so that means the median has to occur between the 7th and the 8th one, right? 1, 2, 3, 4, 5, 6, 7. So that should be here. Okay, do we have even number on the other side? 6, 2, 4, 6. We do. Okay, so that means that the second quartile then, the median, is going to be the average of those, right? If you remember back to section 3.1. So that's going to be 70.5. Okay, so another way to think about this is since we had them occur right in the middle, right, then the median splits those values. Okay, now the quartile 1 is actually the median of the first half of the data. Okay, and so how many data points do we have in the first half? I see 1, 2, 3, 4, 5, 6, 7. So that means 65. That's the middle value. That's quartile 1. And then 78 here would be quartile 3. That's the median of the second half of the data. Okay, and so that's the approximation method. A little nicer than the other one using the percentile method. Okay, well, let's look at letter B because there is a little bit of a difference here. Now in letter B, we should have, I think, 15 speeds. So let's see real quick. 3, 6, 9, 12, 15 indeed. So that means the middle one should be at the 8th value, right? 1, 2, 3, 4, 5, 6, 7, 8. So this 75 here, and we should have a number 3, 6, 7, and 3, 6, 7. Good. So the median is going to be 75. Now in this case, that's a little different than the one above. Now you notice in the one above in letter A, I put a line that kind of separated the halves of the data, right? I can do that here, but what I have to do is make sure that I exclude that 75 that's in the middle there from when I find the medians for the quartile 1 and the quartile 3. Okay, so when I look now, I'm only considering this pieces of the data and this pieces of the data. So it's different than in letter A. So the median is going to be, the quartile 1 is 67 of that first half of the data, and the median for the second half of the data is going to be 79. Okay. Now I want to play with B for just a moment, okay, because there's some other information on the slides that we're going to look at, and what I'm gonna look at here is putting this together with two other values. Okay, so if I take 59 and 67 and 75 and 79 and 85, and I put these together, we get something called the 5-number summary. Okay, so the 5-number summary includes the median, quartile 1, quartile 3, the minimum, and the maximum. Okay, this here is the 5-number summary. Now we have something called the IQR. This is known as the inner quartile range. That is Q3 minus Q1. Okay, so in this case, quartile 3 is 79 minus quartile 3, quartile 1, which was 67. And so what should we get? That should be 12. Okay, and sometimes that is helpful. Now, the reason you need the 5-number summary is because that's what makes the box plot. Okay, so the 5-number summary and box plots. Okay, that's the piece here that we need. So we've got a minimum value. Yep, we got that. We got quartile 1, quartile 3, and the maximum. Okay, so if we ask you to find the 5-number summary, that's what we're looking for. Those pieces you have to know. Okay. Now, what we generally do with this is we can actually build what's called the box and whisker plot or the box plot here. Okay, so how does that work? Well, the discussion that we have, interquartile range, we talked about that already. Okay, there's the formal formula. What I'm going to do is I'm actually going to create the box plot for the data we just dealt with right here in this space, okay, this white space. I know there's another example here. I think it's example number 10. I'm gonna refer you to the solutions, okay, to take a look at those. Again, these are on Canvas. Okay, and it'll be a good exercise for you to play around with. So let me rewrite the 5-number summary that we just found here. So let's see, 59, 67. 59, 67, 75, and then what were the other ones? 79 and 85. Now there are two ways to draw the box plot. You could have it vertically or you could have it horizontally. I think for this case what I'm going to do is show it to you what it looks like horizontally, because there's another question that we're going to look at in a minute that actually has them vertically, and so you'll be able to see both of them. So to do this, we have an axis, okay? And let's I think these were in the context of speeds, weren't they? Yes, speeds and of motorists. Okay, and so this axis then is going to be the speeds in miles per hour. And what we're going to do is we need to figure out how to break up this axis here, okay? And so to do that, I'm going to look at what the smallest speed is, which is 69, and the highest speed here, which is 85. And so I think it's fair if we start at 55. I think maybe going up by 5s would be an okay thing to do. I think we've got enough space for that. And 85. Okay. Okay, now how we do the box plot works as follows. What you do is you begin with the minimum value and you plot it on here and you make it as a dot. Okay, so there's 59. And we're going to do the same thing with 85. Okay. Next, we're going to take care of quartile 1, which was 67, so that should be about here. And then we're going to have 75, okay, as the median, and 79 as quartile 3. So you want to try to make sure that those dots are in a line as much as possible. For mine, it looks okay. Now what we do is we connect the quartile 3 to the maximum and the minimum to quartile 1. Those are the quote-unquote whiskers. Now what we do is we build the box. Okay, so we put a line through quartile 1, a line through the median, and a line through quartile 3, and we complete the box here. Okay, and that's what it looks like. And then we need a title. Okay, and so I think this is we'll call it recorded speeds. Okay, and that's what it looks like. And we don't put any other values, anything like that. Now, in some cases, we do ask you to do some interpretation. Okay, so 25% of the data is here, 25% is here, 25% is here, and 25% is here. This piece here is known as the interquartile range. Okay, sometimes we call that the middle 50%. Okay. Now, what's interesting about box and whisker plots, guys, is let's consider this one. Okay. Just drawing a rough drawing here. Okay. If you had that, what's interesting is this value here, that's an outlier. So we can see outliers in box and whisker plots really, really easily. That's what's really cool about these. Okay. So this is the general way in which we put a box plot together. And again, it always follows from the 5-number summary. Okay. And so again, example number 10, I invite you to give it a shot on your own. You got to be able to make a box and whisker plot. And I would encourage you then to check your answer with what's posted on Canvas. Now we've got one more example for this, and what it asks us to do is some analysis here. Okay, and so this is a box and whisker plot that you see is drawn vertically. And in fact, we're comparing 4 different box and whisker plots. I really like this example. And so when you're comparing 4 different box and whisker plots, what you should notice is that we've labeled them, right? So you know which one is which. So in the other example, if we were comparing, let's say, another officer's speed, I would actually have to label it officer number 1 and officer number 2, okay? In this case, we don't have to worry about that because things are nicely labeled. And you'll notice when we draw it vertically, okay, on this axis then becomes the scale of whatever it is that we're measuring. And so in this case, it's the average spring total phosphorus concentration. And so I think this is dealing with rivers, I believe. Yeah, river basins, okay? Now, this is a little different, this box plot. If you notice on the right side here, they give us a key, okay? So there are a couple of things that they're reporting. So the 75th percentile, the 50th percentile, and the 25th percentile, those are all normal, okay? The quartile 1, quartile 2, and quartile 3. What's different is this top bar they're calling the 90th percentile, and the bottom one is the 10th percentile. Okay, in our case, it was always the maximum and the minimum. Again, it's just a convention of this graph. No big deal. That's why we have this, this key to explain. And then the other interesting thing is they're actually reporting the mean here, okay, as a mode of comparison. And so sometimes we get extra data and information. We like when that happens. Okay, so letter A says, what do the top and bottom bars represent in the box plots according to the key? Okay, well, we just talked about that, right? The top is the 90th percentile. Okay, and the bottom here is the 10th percentile. Nice and easy. Now, letter B says, which subbasin had the highest median average spring total phosphorus concentration? So the median, guys, is this bar. So which one of these has the highest bar? Okay, well, if I'm looking, I think this one is the highest bar. Yes, I think it's higher than this one. What you can do is you can take a sheet of paper and actually move it up and compare. And if you had the sheet of paper, let's say, lying this way, what you're going to notice is this one is much higher. Okay, so which subbasin is that? That is the Missouri. Okay, no big deal. And letter C says, which subbasin had the lowest average spring total phosphorus concentration? And then there's a note here that the lowest is actually those in the 10th percentile. So we're looking for the one that's got the lowest little mark. Now this one is tricky. It's actually a tie, almost a tie, between Ohio, Tennessee, and Arkansas red. Again, what I would encourage you to do is to take a sheet of paper and put it across. And what you're going to notice is that this subbasin right here is actually lower than this guy. So the answer to this one is actually the Ohio, Tennessee. They're so close. Okay. And the last question here, what are they asking for? Which subbasin has the largest interquartile range? To put that even more plainly, who's got the bigger box? I think that's very easy to see. That's Missouri. Okay, so making box and whisker plots is certainly a good thing to have, but you also have to be able to do some interpretation. And then these 4 questions are very good examples of that. We can certainly keep going with a lot more in comparisons. And you got to be able to do some of that analysis. So good news is that wraps up this section. What follows next is everybody's favorite topic, probability. And of course, I'm being sarcastic when I say that. And to those of you who like probability, that's great. Some people get very nervous. And so the book does a really nice job of breaking down the material. So stay tuned for more videos on that.